guys, welcome to day 5 of 21 days of code series with Ozone. I'm here to help with the solution of the first problem for the day, that is house robber. This is a problem that's been asked multiple times by various MNCs in the recruiting process. So let's jump straight forward onto the whiteboard to understand the problem first. Now let's read the problem. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security system connected and it will automatically contact the police if the two adjacent houses are broken onto the same night. Given a list of non-negative integers representing the amount of money each house has, determine the maximum amount of money you can rob tonight without alerting the police. Money. So basically, the problem asks us to find the maximum amount of money if you, being a thief, can rob with the given constraint that you cannot simultaneously rob two houses that are adjacent to each other because there is some sort of security system with which all the houses are interconnected. If you rob two adjacent houses on the same night, it will notify the police and you will be arrested for sure. So that's not what you want. You want to rob the houses in such a manner so that you don't alert the police and also get the maximum amount of money possible on that particular night so that you become rich. As you can see, I have listed down a few cases so that you get a clear understanding of what the problem is trying to ask us and how we'll be building up our solution. If the size of the given array is 0, in that case you cannot rob anything because there is nothing to rob. So you'll be returning with 0 money. In case there is just one house, you can rob that house and be happy. You will get what all money that house has to offer you. But now the problem gets a bit tougher when you have two houses that are adjacent to each other and have certain amount of money. So which one will you rob first? Obviously you will be selecting the house based on the greedy algorithm such that you'll get the maximum amount of money that the two houses has to offer. Basically, you will be comparing the values of the money the two houses has and select the one which is maximum amongst the two. That is, in the given case, when the size of array is 2, you will simply return maximum of nums of 0 and nums of I. Where the nums array is the array that's giving you the amount of money that a particular house at ith index has to offer. Now, we are slowly increasing the complexity of this problem. So if you see, when you have 3 houses, then you have 2 choices available. Either you rob the middle house or rob house number 0 and 2, so that there are no 2 adjacent houses that you need to rob and get arrested. But if we go further into the case where we have the size of array equal to 4, if you observe this example, the size of the array that's given to you is 4 and you have 4 houses and this array contains the value of the amount that each house has to offer. So the house at index 0 has to offer you $1, index 1 $2, index 2 $3 and index 4 $1. Now how will you select the houses that you need to rob such that you maximize your profit and also don't alert the police? So what you can do, if you choose the first house, then you cannot choose the second one, but you can choose the third one, and if you choose the third one, you cannot choose the fourth one. So here one possibility is selecting the values at indices 0 and 1, which will yield you profit of $4. But if you go with another case and you just dropped the first house for instance and selected the second house and the fourth house, that is the houses at index first and third, you will be getting a profit of 3. And there are more cases possible, like if you select this house and leave the 2 houses in the middle and select this house at last, you will be left with $2 at the last. These are the 3 possible cases that you can rob the houses with, and here as you can see the maximum value is 4 and that's the answer here. So we basically need to check for each and every case and decide what is the maximum amount of money we can have. This might give you an insight that this problem is hinting us towards a DP solution because you need to check up every case and the result of current case is more or less dependent on the result of previous case also. We need to check for each and every solution that the problem has to offer and pick up the best possible for us. So as an alternative approach towards this example, we'll be using a bottom-up DP approach to construct our DP array and we'll be calculating our result from that array only. Our array will be of length equal to the size of the given array. So for example, in this case, our DP array would be of size 4 would always remain fixed, because as we have already seen that if the array size is 1, we are left with only one choice, and if the array size is 2, then also we have a fixed formula for deciding the maximum possible money that we can rob that night. So DPR0 will always be equal to nums at 0, DP at index 1 will be equal to maximum of nums at 0 and nums at 1. DP at index 2, that is the maximum amount of money you can rob when you have an array of given size 2, will be equal to maximum of either you will be selecting the array at index 1 or selecting the arrays at indices 0 and 2. DP at index 2 will be equal to maximum of DP of index 1 comma DP of index 0 plus nums at index 2. Now we are gradually approaching towards a generalized formula. So for index 3, the result would be maximum of DP at index I minus 1 or DP at index I minus 2 plus nums at per this index which we are iterating at this moment. So our algorithm should now be more or less clear to you, and if not, it will become more clear when we move towards the code to this problem. Here, first things first, the length of a DP array will be equal to the length of the input array. As I have already mentioned, we will be declaring an integer array and naming it DP is equal to new int nums.length. Also, as we have decided that DP at index 0 will always be equal to nums at index 0 and DP at index 1 will always be equal to math.max of nums at index 0 and nums at index 1. Further moving on, we can use a for loop to fill our DP array. So at index starting 2, I is certainly less than nums.length I plus plus. DP at index I is equal to math.max of DP at index I minus 1 or DP at index I minus 2 plus nums at index I. At last, we will be returning DP at index nums.length minus 1, that is the last element of the DP array. Now, we should certainly be good to go just after handling the 3 corner cases that could yield to a runtime error exception, because we are using indices of nums at 0 and nums at 1. So in the case where we have an array less than size 1, then we would certainly face an issue here. So if nums.length is equal to 0, we can simply return 0, and if nums.length is equal to 1, we can simply return nums at index 0, and for the further cases, our code should be easily able to handle it all. Now let's try to run our code. Let's try out another example that's given with this problem. Now we'll try to submit the code to this problem and wait for the verdict. Alright, it got accepted. Thank you.